Okay, basically, I'm going to talk about a research methods course for undergraduates using computer simulation. And I'm a firm believer that methods is the core. I'm talking to the converted. Methods is the core of psychology. Hallelujah. That it is the most important course our students take. It's the second course of a three-course sequence, going from statistics to methods to applying methods in some substantive area. And as an example of how important this course is, a prior version of the course, I didn't teach this version, Chip Reichart took 205 from Ben Underwood and became a psychology major as a consequence. So it has that effect on you. Basically, we teach research methods. That's basically the orgo of psychology. It's the course the students really hate to take, but at the end of it, they say, Jesus, I actually learned something. And isn't that amazing? And we have, it's a fresh sophomore, junior course. Occasionally seniors take it. It's required, but they should be taking it as sophomores. And we have 3 research papers that they have to do, and they're based on 3 separate research projects. So this first one I do is the first day of class. I bore them completely for an hour, giving the Roediger-McDermott memory study, which after an hour, they have 50% false memories. And I say, welcome to psych methods. Isn't it amazing what you've just learned is not there? We talk about that for several weeks and analyzing it. The second study is the one I want to talk about now, is using a computer simulation to teach how do you actually do real research where you have to collect your own data, except you don't. The subjects are the biggest problem. And so in the third study is something they go off and do whatever they want to do. So I'm going to show you slides basically taken from my presentation that I give to them, that basically simulations are something I tell them that many of us do all the time. We make up data all the time. I always make sure we say when we make up data, we call it simulation. And in the field, there are people who get upset by that statement. But by having theories to organize data, and I say this really helps us, by having our theories, we can simulate our theories to see where we can go with these. And some complex theories are only understandable with simulations. And so I simulate in this particular one data that comes out of my lab. And in fact, I've actually used the simulation to give me ideas of what the right parameter values are to use in experiments. So we simulate subject variables, independent variables you can manipulate, such as caffeine or time of day, and intervening motivational variables, such as how aroused you say you are or how tense you say you are, and an outcome variable, such as cognitive performance. And the simulation actually fits data that comes out of our lab. And I give a little advertisement for the Personality Cognition Lab. And I talk about how we're going to look at these 4 classes of variables. And so we're looking at what are person characteristics? And so this forces them to go off and do literature reviews. I give them a handout, as you'd expect, and the literature, they have to go off and find the literature about what's impulsivity, what's anxiety, if they want. What are these manipulation effects, if they want? What are the motivational variables they want to look at? Now, I make the point they don't have to look at all the variables. It's much too complicated to look at all possible variables. Part of the problem of research is choosing that subset of variables you want to examine in one particular study. And that's a real problem. And it is, of course, that many of my examples in class tend to be caffeine examples because I've given enough caffeine to people. So I give a lot of caffeine and I give a lot of time of day examples. Many students say, I don't want to talk about caffeine or time of day. That's fine. So it's a test of theory, and the model is much too complicated for any one student to look at it. And so their objective is twofold: to better understand a limited part of psychological theory and to try to understand what are the relationships. And it's based on a web-based program, and I'll show you the web-based, but I'm not going to link to it, but I'm going to show you screen captures from it because I don't have the courage that Chip had to go to the website itself. The biggest question is, what should you study? And this distinction, and you have to choose independent variables and subject variables. and try to estimate the underlying model. And so what are the independent variables? The experimental variables are things you can manipulate. Subject variables are characteristics of subjects, and dependent variables. In this particular case, independent variables you, the student, have control over. You can give placebo or caffeine. And this is coded, I tell them it's coded 0-1. When you write this up as a research project, you have to tell me how much caffeine you gave them, which means they have to read the literature. I've had some people give enough caffeine to kill subjects, and other people have given so little caffeine as to have absolutely zero effect. But that suggests they hadn't read the literature very carefully. What time of day do you want to do the study? Anywhere between 8 o'clock in the morning and 10 o'clock at night. Northwestern students will not show up empirically before 8 o'clock in the morning, so why simulate that? What sex of your subjects do you want to choose? How anxious are your subjects if you want to measure it? If you want to measure anxiety, how do you measure it? Go off and look at the literature. Impulsivity, do you want to measure impulsivity? How do you do it? What items would you write? Subject number is a variable. The idea of the simulation is you get one subject per day because there's a confound built in. Subjects are less anxious and more impulsive as the quarter goes on. You can ask intervening variables. So you can ask questions such as how energized they are. And basically, how do you measure energetic arousal? I give a footnote of how to do it. Here's a reference to Thayer. Go read the Thayer paper. And there it is. You ask them, are you alert, peppy, active, and vigorous versus sleepy and tired? It's not that complicated. They can do it. They have to read the literature. How about tense arousal? Once again, the reference to Thayer. Cognitive performance. Now, unfortunately, I mislead them at this point, because I give a very nice lecture about the complex interaction of caffeine and personality and time of day, and a crossover, it's a wonderful triple interaction. They're really set up for that. They think that's what I'm simulating, and I'm not. But some, of course, want to test that hypothesis, because it's a reasonable hypothesis, but it's not there. It's okay. Subjects, if you don't specify the characteristics of the subject, it is allowed to be random. It varies randomly. So if you say, I don't care about the gender of the subject, I don't care about their impulsivity, I don't care about their anxiety, those are just randomly varied by the program. If you specify it, you can control it. And so if you, and they're either from rectangular distribution or a normal distribution. So caffeine, obviously, is just rectangular. What is caffeine? It's really a cool drug, it turns out. What's time of day? It's something that most cognitive psychologists should worry about, but don't. Sex of subject, and roughly half the students want to measure the sex of the subject. They have wonderful hypotheses. In fact, the computer asks what sex is the subject and immediately forgets it. But this leads to type 1 errors, which is a wonderful part of the simulation. What is trait anxiety? What is impulsivity? What are the dependent variables, intervening variables, energetic arousal, tense arousal? What is performance? How much is the cost? What should you test? I say, you can't do everything. Choose what you want to do the study on, and that's the real essence of the simulation. Subjects are not an unlimited resource because it takes effort on the part of the student to collect the data. They actually have to press a button for every subject they run. So they don't want to run thousands and thousands of subjects. Actually, when I do it, I just say, give it all random. It's just much more fun. But they're taught they ought to do it systematically. And of course, they make mistakes when they type it in. I tried doing this in the airplane, and it took me 3 trials before I got it correct, typing in data. So to have some theoretical explanation, do some pilot studies. It's okay. Call them pilot. You can include, some of them students will actually have study 1 and study 2 in their paper. Try to determine what's going on. Here's the web link. Everything I do is at the personality-project.org. All my syllabi are always Revelle/syllabi. I'm not a very creative person. Revelle syllabi, and they work their way through to this link. And the instructions there are basically what I've just given you. And then I will run through this. So you get to assign subjects. Now, when you assign subjects to condition, I learned this from teaching 205 from Ben Underwood. Block randomization is a really powerful trick, because otherwise, if you're trying to get random assignment of subjects and equal cell sizes, you will have runs of bad people at the end. So there is, of course, as you'd expect, in the psych packages, a function to do block randomization, which they can get their blocks set up using block random. Here's what block random does. It gives you how many subjects do you want, how many conditions do you want, and it block randomizes for you. Here's another example of it with a more complicated design. What's the advantage of block randomizing? Here's a nice little bivariate plot, scatter plot. If you've correctly assigned people to conditions, then all your independent variables you've manipulated should be orthogonal to each other. And this comes out with these lovely circles of absolutely zero correlations. This is what block randomization leads to. If you don't get perfect circles like that, you've screwed up your assignment of subjects. After the data are collected, it drops you into a website. It gives you the data. You just copy and paste it into R. And we actually have a, so here's, once again, the instructions you get. You get all these redundant instructions, redundant what I just told you. The bottom of the page, how many subjects do you want? 100 is a good number. Here's what it looks like when you collect the data. You've got to go through and press a button for the conditions for each subject. But if you're lazy, as I am, you just let it randomize. Or if you don't care about it, I don't care about the gender of the subject, just forget it. Don't let it be random. I don't care about their impulsivity. Fine, don't specify it. Here's what the data look like when it comes out in your web browser. You suck it into R, and it looks reasonable. An undergraduate of mine, Katie Funkhauser, said, your tutorials in R are much too complicated. Here's a 2-pager. She was a 205 student in another course. She took it, wrote it. So I recommend Katie's 2-page summary of how to use R to do the psychoanalysis. So just you read the data, you read it to the clipboard. That's not that complicated. Turns out some people don't know what a clipboard is. You sort of pause. You say, oh, well, when you copy something on your computer, it's in the clipboard. Oh, okay. But it's just amazing. Describe, you always want to describe your statistics, is a way of finding outliers, a way of just, what are the basic descriptives? It's not that hard to describe data. It's one line. You want to do a scatter plot of your data. That's also one line. That's a pairs panels plot that allows them to see what's going on. You want to blow up a scatter plot to take just some part of this. One of the things these kids are learning is how to do presentation quality, publication quality graphics without knowing it, and doing it in just 3 lines of code. They've had stats, and it's embarrassing what they've learned in stats. They don't remember any of it anyway. So I teach them, I said, everything you learned is wrong. We're going to do the linear model. And here's how you do it. And here's some basic assumptions of it. And it's that line of code. You've done the linear model. You get nice output. You want to add pictures to it. So how do you do a graphic? I have helped students make really wonderful 3-way interaction 2-panel graphs that aren't really there because they're a type 1 error. And I apologize to them afterwards, and they turn in their paper saying, it was a wonderful graph you did. I'm really glad I helped you do it. It's just not there. It's a false positive. Why do I like simulation so much? We know truth. It's the only time we ever know truth. I know exactly what's there. I know that caffeine affects energetic intense arousal. I know the time of day and impulsivity have an interactive effect on energetic arousal. I know that because I put it in the model. I know that energetic arousal makes you perform better, not curvilinearly, just monotonically. I know that sex has no effect on anything, and that there's no caffeine by impulsivity by time of day interaction, even though I've been talking about it for several weeks ahead of time. Type 1 errors. We talk about type 1 errors happening 5% of the time. No, it's much more than that because it's experimenter-wise error rate. These kids, the more ambitious kids, are doing far more analyses. The really best students get the most type 1 errors. they really learn something from that. When they do their third paper, they say, do you think this is a type 1 error? I say, oh, no, this is a real effect. How do I know? I don't know. But it's just an interesting problem. We talk about power. I know there are some effects that are subtle, and they won't find them. They're there. I actually do a meta-analysis when they turn in their paper, asking all the students what they found. It's a wonderful way to show the meta-analytic techniques pick things up. Do the students learn from this? Well, I'm not as brave as Pascal, but they've learned to take a really important problem apart and look at the parts of it. They seem to understand type 1 errors much better. They seem to understand power much better. About once every 2 years, some kid figures out mediation analysis. Because, in fact, it is a mediated model. Caffeine makes you arouse. Arouse makes performance. So you put caffeine in the model and performance in the model, you get a nice caffeine effect. You put caffeine in the model and arousal in the model, you get a nice effect. You put arousal and performance, you get a nice effect. You put caffeine and arousal and performance, there's no effect of caffeine. It doesn't happen very often, but when it does, I just, yeah, yes. And they're really happy too. I said, you have just learned a graduate level concept as a sophomore. They also are exposed, I like to say they learn, but I will say that to be more honest, they're exposed to how to do publication quality graphics and statistics using the lingua franca of statistics, R. And and if you try it yourself, and that leads you through, go to that link, and you can try this simulation yourself, and you do all the analyses yourself. That's it. Questions?
Have you ever thought of expanding and turning it into a video game?
That's what R is. Right. Well, one thing you can say, basically this is a PHP script, it turns out. And so for those who want, you don't have to do my simulation. The simulation is, here are IVs, here are DVs, here are mediating variables. What's the relationship? You can put up the labels anything you want. And so I'm very lazy. It's always the same simulation. And they don't learn from the students last year that sex didn't work. They always they always look for it. A video game of collecting data? I'm not sure how to.
Well, we actually developed 2 games where we simulate what you're doing, but with different things. One's called heavy distributions and one's called oceans. To teach sampling and to teach about copper intervals and about copper.
Okay.
But mostly it's written, the language of Lord of the Rings, because that's what the students like.
Yeah, okay.
And the idea is it's almost exactly what you're trying to do, but it's through a video game, and we're evaluating it and see how well people like it. But it's very similar.
Yeah. The advantage of simulations is you know truth, and that's what I really like about it. I know truth. Their job is to find truth.
Yeah, that's what they're trying to do.
And that's, you're acting like God, basically, because you know truth. It's very unusual we have a chance to do that.
How do you grade the assignments?
On their writing skills. If the student says, I chose subjects 1, 0, 2, I gave them the values, I said, you didn't pay attention in class. You were told you had to tell what the things were. I grade, all 3 papers, the first 2 papers I grade with the students, one-on-one, grading it with them, working through the writing, what's the logical thing. I grade it on, not do they get the right results, I don't care. Do they analyze it correctly? I care about that, but I probably help them on that, so that you can't grade on that. Do they do a good literature review, and do they understood what they found? And it's hard to look a student in the face and say, that's really a crappy paper. And so I tend not to. I do say, please do that one again. So they then come back again sometimes. But this is, you work on a one-on-one. It's not a point. This is a question I asked you last. I don't know how to do points because I teach too much measurement to believe in points. It's, you know, it's this monotonic. You know, some papers are better than others. My time is up.